So the question 69 from June 2020 mathematical science paper. So we have f of xy is given to function x square minus y square by x square plus y square, and another one is 0. So here xy is not equal to 0 comma 0, and in this case it is equal to 0 comma 0. So we have to find which of the following statements are true. So option 1. So if we put y equal to m of x, so it can be written as x square into multiplied by 1 minus m square, and this is x square by 1 plus m square. So after simplifying it, so it put in the value over here, right? So this in this f of xy, so it will be 1 minus m square divided by 1 plus m square, which depends on m. So we can say that f is not continuous at 0 comma 0. So our option 1 is incorrect. So let us check with option 2. This, if we put this x is equal to r of cos theta and y is equal to r of sine theta, then put it value over here. So we'll mapping this f of xy with f of r theta. So here we will have r square multiplied by cos square theta minus of sine square theta by r square, so which is nothing but cos of 2 theta, so which is bounded for all theta. So our option 2 is correct. F is bounded in the neighborhood of 0 comma 0, right? This is zero comma 0. Now check with the option 4, and the option 3 is incorrect. So we have to find the option 4 is the directional derivative at 0 comma 0. Okay, directional derivative at 0 comma 0. So we can write it as limit h tends to 0 f of 0 plus u1h and 0 plus u2h minus f of 0 comma 0 by h, right? So we can also write it as limit h tends to 0, so it is simply f of u1h u2h comma this u1h u2h minus of 0 by h, right? So if we put the limit h tends to 0, so it is u1 square h square minus u2 h square by u1 square h square plus u2 square h square. This is whole by h, right? So after simplifying it, we will find that limit is there h tends to 0. Now the upper portion is u1 square minus u2 square by u1 square plus u2 square, this whole divided by h, right? So as we know that h tends to 0, the limit doesn't exist. So our case, the option 4 is not correct. So we have only the option 2 here is the correct one. F is bounded in a neighborhood 0 comma 0. Question number 70. Let P be R2 to R, this mapping be defined by P of xy, mod x when x is not equal to 0 and mod y when x is equal to 0. So we have to find which of the following of statements are true. So option 1 is given, the PA of xy equal to 0 if and only if x equal to y equal to 0. Right, so we have already given that P of xy is 0. It means mod of x when x is not equal to 0 and mod of y when x is equal to 0 it will be. So mod x equal to 0 and mod y equal to 0, which implies x equal to 0 and y equal to 0. So if x equal to y equal to 0, then only this P of xy, it will be mod of y equal to 0. So that is, the P of xy is only equal to 0 if and only if x equal to y equal to 0. So option 1 is this correct option. It is true. Okay, let us check with option 2. So P of xy is greater than equal to 0 for all xy. We know that the modulus function, yes, modulus function is always non-negative. So P of xy should be equal to greater than 0. So option 2 is also correct for all xy. Now let's check with option 3. So now if x equal to 0, so we can write it, if it's x equal to 0, then P of alpha x alpha y, right? So it can be written as P of 0 comma alpha y, which is nothing but mod of alpha y. We can write mod alpha mod y, which is simply alpha of mod alpha f xy. Now again, if x is not equal to 0, then P of alpha x alpha y can be written as simply P of alpha x comma 0. It is again mod of alpha x mod alpha mod x, which is nothing but alpha of x comma y. So we can easily infer that P of alpha x alpha y, it is mod of alpha P of xy for all alpha belongs to the space, is element of the real space R, and for all x and y. So our option 3 is correct. So let us check with the last option, that is option 4. So this relation is given. So if we put P of minus 5 plus 5, 6 plus 6, so it is nothing but 12. And if we put P of minus 5 comma 6, so it is 5. And P of 5 comma 6, 12 to 5. So here it is 12, which is not equal to less than 10, right? So in our case, the option 4 is incorrect. So this relation will not hold for all x1 y1 and x2 y2. So the question number 70, the correct options are option 1, 2 and 3.